Manufacturing data is everywhere on a plant floor: sensors, PLCs, MQTT brokers. But it's almost never in a form an application can use without custom integration work. Every new monitoring tool, every new vendor, usually means another point-to-point connection built from scratch. This demo shows a different approach using a standardized interface called i3X. Prosys Forge sits at the edge. This is where raw data gets refined. It connects to the OT data and standardizes that into Sesme's smart manufacturing profiles. Definitions of what a piece of equipment is and what data it produces. Forge delivers the result as a live i3X endpoint, a single standard interface any compliant application can connect to. On the other side, Nortal builds their monitoring and visualization application using the i3X interface together with an AI-accelerated development framework. That app connects to Forge's i3X endpoint, discovers the available equipment, recognizes the standard models and updates visuals automatically, and pulls real-time sensor values with no custom integration against Forge required. The point isn't just that these two products work together, it's that they didn't need to be built for each other. Because both sides speak the same standard interface, the architecture can scale to any other i3X compliant platform. That's the idea this demo is built to prove app portability in practice.
We'll start by navigating to Sesme's SM Marketplace, where we can download the SM profile we'll be using. Next, we'll import the profile into Forge. Forge's cloud library automatically handles all the dependencies required by the profile. We can then create a connection to the OPC demo server that provides the production data. Once the connection is established, the server appears under Data Sources in Forge's address space. The server contains 2 production lines, each with multiple pieces of equipment. For the capper equipment, we can use the SM profile we downloaded earlier. In Forge's address space, we'll create a new node based on the types defined in the SM profile. We can then easily map values between the newly created node and the corresponding server node. We can also enable data historization for these nodes. The equipment data from the server is now fully mapped to a standardized structure and ready to be used with i3X. Forge provides an i3X compliant endpoint, allowing any compatible i3X client to connect to it.
In this part of the demo, we'll show a practical example how AI-first software delivery can revolutionize software development, shortening the path from requirement to working application and putting control in the hands of end users. The dashboard you'll see is just one example of the journey from i3X's structured, modeled data to a ready application. An architect, UX designer, and product manager debate what success looks like. Operators want new equipment on the dashboard without touching configuration. Engineering wants the app to match spec, line for line. The result, a documented vision statement, success criteria, and requirement specification. And later changes happen by adding or updating requirements, not code. 2 production lines will prove it holds up. Before a line of UI code is written, the architecture gets decided and recorded. Subscription handling and session resets each become an ADR, with a safe polling default. Then the spec itself, a dashboard file naming which nodes appear, which widget each one gets, and what's required versus optional. None of it is guessed, and none of it is silent. Where options exist, the AI asks first. It connects directly to the live i3X interface, takes the SM profile as its baseline, walks the asset hierarchy, and samples actual values, including the gaps like a die temperature sensor with no data. The layout follows how an operator scans a panel: status and state first, alarms next, then production metrics, process variables, and equipment lifecycle last. With the spec settled, the AI builds the interface itself, a dark, control room styling pass with amber status indicators laid directly over the approved structure. Then it writes the test suite, unit tests, integration tests, end-to-end checks against the live i3X endpoint, and runs the whole thing before calling it done. Watch the dashboard update as it does. Fields that read "not available" a moment ago start filling in with real numbers. Good parts, strokes per minute, cycle time, line 1 is live, and every widget on screen traces straight back to the specification, nothing shown that wasn't written down first.
Adding another piece of equipment to a production line in Forge is just as simple. Create another node of the same type and then map it to the corresponding nodes on the server.
Now the real test, a second production line that didn't exist when the app was built. Before the script runs, line 2 shows nothing. From that one mapping, a configuration script pulls in the history template and data mappings in a single pass. The app doesn't need to be told. It discovers the new equipment itself over the same i3X interface. No dashboard code changes, no redeploy, 2 lines, 2 dashboards, 1 SM profile, line 2 live within seconds. That's Nortal AI Kit, spec-driven, AI-built, and ready for what's added next.
Here's the real value of this setup. Every custom integration is a cost that keeps climbing. You pay for it again every time something changes. Forge, i3X, and Nortal change that. Build against the standard once and it's online the day it hits the floor. Hours, not weeks. And because it all runs on one open standard, you're never locked into a single vendor's roadmap. Whatever comes next, it's already built to handle it. Built once, reused everywhere.